Hello and welcome to Math with Beth. We are going to look at graphs today, cubic graphs, cube root graphs, and square root graphs, and also deal with some of their transformations. So first, it helps to know the parent graph, but remember, if you do not have all of these memorized, you can always recreate them really quickly by just picking x's, plugging the x's in, and finding the y's. So with the square root graph, instead of doing -2, -1, 0, 1, and 2, which is what I choose a lot of the time, I'm going to pick numbers that I know will be able to be put into the square root. So first of all, we can't take the square root of a negative, so I'm not going to pick any negatives. So I'm going to start with 0. Instead of using, well, I'm going to use 1 because we can do the square root of 1, but instead of using 2 or 3, my next one I'm going to use will be 4. And then let's go ahead and just add one more, 9. So I'm choosing x's that I know I can take the square root of instead of having numbers where I get decimals. So plug them in. If I take the square root of 0, I get 0. Square root of 1, square root of 4 is 2, and square root of 9 is 3. If you wanted to do another one, you could do 16, but that's plenty. So I'm just going to use this for my parent graph numbers. And let's go ahead and just graph that so we remember what the parent graph looks like. 0, 0, 1, 1, 4, 2, and 9, 3. So it's a curve that starts at 0. So now, how would I graph the same type of thing, but with all of these changes? Well, this -2 is going to flip it and make it go at a different angle. This -3, because it's inside the square root, is actually going to move us to the right, and this is going to move us up. But instead of just doing all of that on my own, because that can get tricky, I'm going to use this table to just apply these changes and make it a lot easier for myself. So the only thing that will ever affect the x values are things inside the function. So in this case, the function is the square root. So the only thing I have to deal with is that -1. And remember, for the x's, it's always the opposite. So -1 means I'm really going to go and add 1 to all of my original x's. For the y, I need to deal with this -2 that's being multiplied out here and this +3. And you do not do the opposite. So when you see a -2 out front, you're going to put a -2 times the y. And when you see that +3, you're going to put +3. So opposite of what's happening inside, but what's happening outside, you just do exactly that to the y values. So looking up at my original parent function numbers, 0 plus 1 is 1, 1 plus 1, 4 plus 1, and 9 plus 1. For the y values, I'm going to put those in, but I'm going to multiply by -2 and add 3. So this would give me 3. Plugging in 1 would give me 1. Plugging in 2, because that would be -4 plus 3 would be -1, and plugging in 3 would give me -6 plus 3. So now those are the numbers that I'm going to graph. 1, 3, 2, 1, 5, -1, and 10, -3. And just like I thought, it should look like the original has changed shapes and was flipped. It moved 1 right, 3 up, and flipped. Let's do the same type of thing with an x to the third or a cubic graph. So again, this would be considered the parent graph because there's nothing that's happened to it. Nothing's been multiplied, added, or subtracted. So what would happen with the parent graph? So this time I am going to do my normal -2, -1, 0, 1, and 2 because I know I can cube all of these numbers. -2 to the third power would be -8 because it's -2 times -2 times -2. -1 to the third power would be -1. 0 is 0, 1 is 1, and 2 is 8. So what is this going to look like? -2, -8. -1, -1, 0, 1, 1, and 2, 8. So it is kind of an S graph. Okay, so same idea. If now there's been some changes to that graph, we can use the parent graph numbers that we just found. Okay, so I'm just going to use this table that we just found and apply all of these changes to it. So again, what's the only thing that's going to affect the x? Anything that's inside the function. So inside what's being cubed. So again, I'm just going to have to add 1 because I do the opposite to the x. For the y, I'm going to have to multiply by that 1/2 out front and also subtract 3. So opposite of the x's, anything that's happening outside, you do as is. So -2, so we're taking these numbers and adding 1. We're taking these numbers and multiplying by 1/2 and subtracting 3. So -2 plus 1. -1 plus 1, 0 plus 1, 1 plus 1, and 2 plus 1. -8 times 1/2 is -4, minus 3 is -7. -1 times 1/2 is -1/2, minus 3 is -3 1/2. 0 minus 3 is just -3. 2 times 1/2 is 1. 1 minus 3 is -2. And 8 times 1/2 is 4. 4 minus 3 is 1. So let's see what that's going to do. -1, -7. 0, -3 1/2. 1, -3. 2, -2. And 3, 1. So here's our S. So it moved 1 to the right, 3 down, and got a little bit wider. Okay? And our last graph that we're going to do the same type of thing for is the cube root graph. So again, this would be the parent graph. If you don't know these points, it's very easy to recreate them. Just think that whatever your x's are, you're going to be putting in here and taking a cube root. So again, I'm not going to pick just any numbers for this one. So negatives are okay because you can take the cube root of a negative, but I'm not going to start with -2 because that's not going to work nicely. So I'm going to do -8, because I know I can do the cube root of that. -1, 0, 1, and 8. So plugging in -8 here, I would get -2. Plugging in -1, plugging in 0, plugging in 1, and plugging in 8. So this is the parent graph. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So it is also an S. It's just a sideways S graph where the cube was up and down S. Okay, so that's what the parent graph looks like. And here are the numbers we're now going to use to apply any changes that are happening. Okay, so this is the only thing that's going to happen to the x. And make sure you do the opposite. This and this, we're going to do to the y exactly like we see. So -2 times y minus 4. And again, it's going to be these points that we're plugging in and doing the changes. So -8 minus 1, -1 minus 1, 0 minus 1, 1 minus 1, and 8 minus 1. That was the easier part. Now for the y's, we're going to do all of this. Multiply by -2 and subtract 4. So -2 times -2 is 4, minus 4 is 0. -1 times -2 is 2, minus 4. 0 times anything is 0, minus 4. 1 times -2 is -2 minus 4. And plugging in 2, I get -4 minus 4. So now I just graph these points, and hopefully it will look like a sideways S, but it should be flipped because of that negative out front. So instead of going this way, it should look backwards. So let's see. -9, 0. -2, -2. -1, -4. 0, -6. And 7, -8. So it is a sideways S that has flipped. And because of that 2 out front, it has stretched out some. So it is a wider S, and it has flipped directions because of the negative. Okay, so for any graph, if you know what the parent graph looks like, or if you can recreate it, you can use these same rules to make changes to the X and the Y and get your new points and graph from there. I hope that helped, and I will see you next time.